Thank you. So I'm going to talk about CQRS. I'll start with me quickly. I asked some of my colleagues to write the about me, and that's what they said. I'm a staff engineer at Tim Group, which means that I'm responsible for influencing how the technology organisation and the company work and how we operate with the business. Tim Group are a fintech company, and I think we're best described as a bit like Facebook for finance professionals. But if you don't give good advice, then you're not friends anymore. During the talk, I'm going to go into some of our domain a bit deeper, so you'll get more of an idea of what Tim Group do through that. So I'm not going to say anything more about that. So this talk was inspired by an interaction I had quite a few years ago at Tim Group. We had a guy called Greg Young come to Tim Group to help us with CQRS and event sourcing. Who's heard of Greg Young? Okay, so Greg Young coined the term CQRS back in 2006 at QCon San Francisco. I hope that's right. And I stood in front of the group at Tim Group, and I said, "This is Greg Young, and he's going to talk about CQRS." And he turned around to me and said, "No, I'm not." He said, "I'm going to talk about event sourcing." He said, "I only talk about CQRS as a way to explain why you need event sourcing." And at that point, that was a huge aha moment for me, where I kind of realized more what CQRS actually was. So at its core, we're separating our models that we're using to represent the read side of our system and the write side of our system. And that's pretty much it. A lot of people elaborated on that, and there's lots of much more complicated things that have come out of it, which are still kind of carried the branding of CQRS. But at its core, it's something quite simple, which hopefully this talk was supposed to get that across, but then I think, let's see. So what I'm going to do is I'm going to walk through something that we did at Tim Group. There's a lot of details cut out, and it's obviously very simplified. At each stage, people will probably think, I would probably have done something different. That's okay. I'm trying to lead you straight towards event sourcing. So different things that you could have done at each stage would probably still be CQRS, maybe, but that's not the point. It's to see how the sort of story of how we got to event sourcing and how we found it compelling. So the first two words, commands and queries. Command is an imperative. We're asking the system to do something. So in any system that we build, we always have something like a command. We might not call it a command, but it's there. We're asking the system to do something, to change something. It represents the intent of the user using the system. And a query is you're asking the data that you already have. You're asking a question of the data you already have, like I've written there. Okay, so I'm going to talk, hopefully, the simplified domain of trade ideas, which is our domain in Tim Group. So we have authors, we have recommendations, and we have recipients. So John recommends buying Vodafone to Jim. Alice recommends selling Barclays to Bob. That's all we do, really. So if we talk about the commands in the system, well, the only real command that I'm going to talk about today is that we're going to ask the system, an author who's going to be recommending trade ideas, who's going to be recommending investments, is going to ask the system to recommend investments. So that's the command. They're going to say, remove this recommendation from Vodafone to Jim, and they're going to say, add Bank of India to Steve. And they're telling Steve to buy Bank of India. So what does the author want to see? Well, the author wants a model that represents all of the people that he's connected to and what he's currently recommending, so that he can decide what to change, what new commands he wants to ask the system to perform. And if you're a recipient, so you're the person receiving the commands, you want an entirely different model. You don't care who sent it, you just want to know the sentiment. So you want to know that 4 of the people that are recommending you investment recommendations are telling you to buy Vodafone, and 3 are telling you to sell. So you get an idea of what the street is trying to tell you. So this is some code. I've written it in Scala, mostly so it fits on the slide. That's it, really. So the model, this is a model, like I've written here, think hibernate. So think you've got a hibernate type model. We still have hibernate in our system. So a recommendation has a list of recipients, has a stock and direction, and a recipient, and then an author has a list of recommendations. So that's the same list that you saw on the other slide. And there's one repository which can save and retrieve all the authors. So what I talked about before about separating the models of reading and writing, you're probably not doing CQRS at this point. I think there's a very strenuous argument that you are, but I won't go there. So at the database level, you're going to have 3 tables, a bit like this, with foreign keys between your recommendation and author, and a bunch of recipients of that recommendation. Okay. So when I process our command, I'm going to do something like this. So I'm going to get my author object, my hibernate active record object. I'm going to directly operate on it, remove recommendations from it, add new ones, and then save it. Okay. So this is kind of where we started / are starting in the talk. So what does the author want to see? Same as what we had before, and you might do something like this. So you're going to pull out the author object, and then you're going to build a model that looks a bit like this. And then if we're a recipient, we're going to pull all the recommendations out. We're going to filter by, that should be recipient ID. We're going to filter our recommendations, and we're going to produce this model that we described before. The key point is that we're operating on the same underlying model. So at this stage, we want to solve problems. So the problem we've got at the moment is that it's too slow. Maybe because there's too much data, maybe it wasn't slow at the beginning, but now it's too slow. And in my sort of connection to our real system, it was too slow and we did something about it. So our diagnosis is that the read side, so the display that we're seeing, that was the counts of recommendations for each recipient, for each author, for each stock, is dictated by how we write the data. Because we write the data as individual recommendations, the way that we read that data has to be from that source of lists of recommendations. So the simple thing we can do is just not use that model. So we can go directly to the database and use our own model, like this slide says. So we're going to not use this ORM layer is the same as that one. We're going to switch it for a new one. One of the pieces of feedback that I did before was that I kind of removed the ORM layer entirely. Actually, we're just replacing it with another one, which is handcrafted. And I'm going to do this in the other way around. So now we basically do an SQL query on the database. We build our model directly off of that. We cut out Hibernate. And I think, who thinks we're doing CQRS now? You're supposed to put your hand up. I think we're doing CQRS now. We've got two different models. They're representing different use cases. And if I go back to here, I've seen this example as trying to describe what CQRS is, and I think it's useful to have something simple where actually we've got a different interface that is going to return an entirely different model. So from our code perspective, we're not operating on the same model for the read side and the write side. So our system is still not scaling. We keep becoming more popular. We keep having more data in our database. And it's getting slower and slower as time goes on. For our really popular clients who have loads and loads and loads of connections, it's even worse. So we're actually punishing our clients because they need to count more rows in the database and do more work on the read side. So what we're going to do, we're going to cache the data. So we're going to cache that model of counts, and we're going to look a bit more like this. I know this is a bit of a busy slide, so sorry. In one of Greg Young's tutorial videos, he says, introduce a cache. You had a problem, you introduced a cache, now you've got two problems. So what problems have we got now? All of these things that we're doing here are trade-offs. So we've built a really fast read model. So our model that we had where we can read ID accounts directly, and it's going to be based on which recipient you are. But now the data is going to go more and more out of date. So we've traded off the speed of access to the data for the staleness of the data. And this was my way of saying that you can move this logic around so that it's you can make building your read model faster or slower at the expense of the query time, which is one of the key things in sort of doing CQRS, is that you're doing these trade-offs and using the words to describe those trade-offs. So that's just a slide that shows that. So the next problem, as we described, is the data is going stale. So now I've got a really fast cache, but it's out of date. And it's getting more and more out of date as we become more and more popular. So our diagnosis is kind of obvious. The amount of data, if we're transforming the entire data set every time, then it's going to be slow. And as the data set gets bigger, it's going to be slower and slower. So applying small changes are going to be faster for a mostly up-to-date model. So the solution, we start to broadcast events onto an event bus and then play those events onto our read models, which means that we're going to apply much smaller changes, and we're much more likely to be able to keep our model up to date in quote-unquote real time. So what is an event? An event is a fact. It is true. It's already happened. And it represents the behavior of the system. It's a behavioral model rather than a structural model. So if you think about the third normal form structure that we had before, it's not really saying what has happened, it's saying that this is the current state of the world. Whereas a behavioral model is saying, this thing has happened, now this thing has happened, now this thing has happened. So my poor examples, user added, user has been added to the system, recommendation was added. That's it really. So what does our command processor look like now? Well, really all we're going to do to start with is just raise the events. So we're going to write the data to the third normal form database that we did before and just additionally raise events on the event bus. Awesome. And then we can have a projection. So a projection is some code that takes the events and builds a read model. Now I can listen to these events and I can build a model. So in this case, I'm just going to build it in memory because I don't actually need to persist it anywhere. So this is looking quite fun. And we end up with a system like this. And you'll see a lot of CQRS systems that look like this. I've worked on a few. But there are some flaws. There are some challenges that can be worked through. But what happens if there's a mistake when we publish the events? Go ahead. Was there a question? No. What happens if there's a mistake when we publish the events? The most obvious thing is that we've got to now do a two-phase commit across two different systems. We've got to do a two-phase commit against our system of record. System of record is our master copy of the data, by the way. Source of truth are the words that mean it's the true copy of the data. And our event bus in order to make the system reliable. What happens if there's a mistake when we wrote our projection into our read model? And what happens if we just didn't want that read model anymore? We wanted a new one. We wanted a new use case with a different access pattern. With this architecture, there's going to be challenges. And as I said before, I've worked on systems like this, and those challenges can be overcome. But I see problems with this system. So how do I keep my master database in sync with my read models, as I said? And how do I bootstrap new read models? Those are kind of the two key things in there. And the kind of next step from here is to say, well, actually, let's just make the events the system of record. Make the events the master database, and make your third normal form database or any other read model that you want to build simply a derivation or projection of those events. So we're already at event sourcing. So I've called it event sourcing 101. I know that there are real-world problems that make these kind of rules not hold quite true, but at its core, this is event sourcing. We always keep all events. Any event that we've ever made in our system, we store in our event store. We never mutate them. We don't change events that have already been written. As I said before, events are the system of record, and we play events into our read models to produce use case specific access patterns. So depending on exactly what the query is, what the user wants to read, we build a read model that's specialized to that purpose. We always play forward from 0 to now. So we never start in the middle of the event stream. It's very hard for me to say that because we read backwards sometimes. So what does our architecture diagram look like now? So we removed our system of record database from down here, and the event store is now a kind of combination between our database, our sort of system of record database that we had before, and an event bus. It's kind of both combined. And what we do is, in order to make decisions about the events that we're going to raise, Before we would have used the third normal form schema. Now we're going to use a read model, which could also be the third normal form database, but it's a projection of the events. It's a derivation of the events. And then we can produce read models in our other read model domains to our heart's content. So that's kind of the basic event sourcing architecture. And what does our command processor look like now? The real difference is that now we still validate our command, probably using the read model that we had before, which is still the database. But we simply save the events in the event store. And then this method here, apply, is now a sort of convention to say this is now applying an event that has already happened. So whereas this command here hasn't produced events yet, those events will be saved and then they'll be played back into this method here. And what I've done here is said, well, actually, when I receive this event, just do exactly what we were doing before against the third normal form database. I've got an unfinished slide here. The intent was, well, actually, we can just remove all of this and build an in-memory model, and it will be much faster than touching the third normal form database, and we can get rid of it entirely and cheer that we don't have to use Hibernate anymore. Nothing wrong with Hibernate. So what else can you do with event sourcing? The most obvious thing is that you can go back in time now. Because you stored all the events that ever happened, you can produce snapshots at any point in time. So one example that you can see is, I hope you can see is quite useful here, is we can see the sentiment of a stock through time. I've been told about 20 times that long short is not the same as buy sell, is the same as buy sell, but I didn't change the words. So long means buy, short means sell. So this is saying, we started off really with loads, really strong buy signals, and then as time went on, we were kind of wanting to sell whatever stock this is, which is an unnamed stock. So this is really useful. And another thing that we do a lot is we have queries on our data, and we look at the data, and they say, oh, this stock is missing or something, and we look at the data, and the data doesn't answer their question. So we have to say, well, what time did you ask that question? And we can replay our events to that exact point in time, and then we can see what the problem was. And this happens quite a lot in our business, and it's very valuable to have that entire history of data. So what do I think CQRS is? It's pretty much doing good architecture. What I imagine most people who have had to scale a system would have been doing CQRS, but they may not have called it that. They may not have used the terminology that is used in CQRS. It's trading off, making trade-offs amongst different aspects of the system, moving business logic around, moving business from your write side to your read side, introducing more complexity to make your pipeline flow quicker, things like that. I don't think it is an architecture as such. I know I said it's doing good architecture, but the architecture that you come up with is not CQRS. You went through a process of thinking about the system in terms of CQRS, but the architecture wasn't CQRS. I don't think it's an architectural pattern, framework, or prescribed way of doing things, and I don't think it's event sourcing. I think that event sourcing is a way to do CQRS. In some cases, better, cleaner than others, but I wouldn't tell people you have to do event sourcing. It's about solving your problems, solving the problems that appear in front of you, and looking at the best options you have to be able to trade things off against solving them. bit early. I've got 2 more slides. So, the core kind of places where I got information from, Greg Young, obviously. If you're serious about CQRS and event sourcing, he came to Tim Group for 2 days or 3 days, can't remember, and he added a lot of value and really helped us. Udi Dan is another big person in the CQRS community, and his course, Advanced Distributed Systems, is really worth watching. The videos, the quality of the videos is a bit awful, but the actual content is quite high. And our event store libraries that we've built up over the time, which we've just put on GitHub, I wouldn't call it open source, but it is on GitHub, and you can get it. People are welcome to use our libraries and ask us questions and stuff. We built our libraries based on Greg Young's event store. So Greg Young has a product called Event Store, and it looks like a very good product, and with some very cool features. And just by using it, you'll learn a lot about event sourcing. So I wanted to talk a little bit about what an event store looks like, about what the API looks like. So I've called this function read to forwards, and basically what it does is whatever position you pass in, it's going to read you 2 events, and that's it. So if you ask your event store to read 2 forward 0, it will read that event. So event 1. Oh, wrong button. Event 1 and event 2, and it will remember that it's read up to event 2. So next time, it will read, you say, read forwards from 2, it will read 3 and 4. Read forwards from 4, it will read 5. And then it will keep reading 5. And it won't have anything until something appears, and then it will read 2 again. So that's really the protocol of an event store. Quite simple. And this is a sort of high-level description of our APIs, which are written in Java. I think the original version was written in Scala. Justin? Yeah. Then we didn't do that. We wrote it in Java. As I said, did I say that? It's highly influenced by Greg Young's event store. So the API and the way of thinking about the system is based on that. But it has a bunch of different, well, when I say a bunch, I mean 2. Different implementations. One is in memory, and one is a MySQL-backed database. The really cool thing about having in memory is you can write really nice end-to-end tests, and it's really fast because you can inject events into your entire system and test that your system's working, and it's fast. You don't have to interact with a disk or with any real system. So that's nice. So, how long got? 1 minute. Writing an event, you say write stream, you have to write the stream that you're writing to. And then you write your serialized events and the expected version. The reason you write the expected version is if you want to have some consistency between the data that you were using to make your decision and the data that you've written, such that the underlying data hasn't moved on by the time you've written it. So you're sure that, your business rule says your car has 4 wheels, and you try to write a 5th one, and it says, the data's moved on. The stream's moved on underneath you. This is an example of reading, and you can say, again, which stream you're reading, and you push it into your model. Again, from event number is important. So you can keep running this in a loop, keep incrementally updating your models. We also have 2 different other ways of reading the data. You can read the entire event store, all of the event streams, or you can read a particular subset of them, a category, we call them. So I think that's it for what I wanted to say. So thank you very much. And any questions?